It's great to see everyone here. My name is Sandeep. So I'm a chief scientist at Poseidon, which is a new incubation from Story, funded by A16Z. So I'm really excited to be talking about that. I'm also a chief AI officer at Story, and in another life, I'm also a professor at UT Austin. So broadly speaking, I work on generative AI, distributed systems, and robotics. And my interest in the intersection of AI and crypto actually began during my PhD at Stanford. Okay, so today we're seeing a race to train the world's best generative AI foundation models. And there are actually three key ingredients to train the best models. So the first is compute, but this is largely commoditized and monopolized by NVIDIA and AMD. So if you have enough cash, you can buy a GPU. But the second ingredient is actually model architectures. So you might think at a first glance that a model architecture is actually your IP and your point of unique differentiation. But I would argue that they're quickly becoming commoditized. So at the start, we first saw OpenAI, and then quickly Anthropic caught up. And then now you're seeing very small startups with lean teams like DeepSeek quickly catching up. And if you peer under the hood on a technical level, people are largely just using transformers, diffusion models, and mixture of experts, right? So if you have a short-term advantage, it might just last you 6 months. But the third ingredient to train the world's best models is data. And I don't mean common data that everyone can just scrape from the internet. I mean rare events. So let's say it's snowing in Seoul, and your dash cam sees a new traffic sign. That's a rare event, so how do you curate this edge data? Or it could be people speaking in rare dialects or accents in a call center with some noise. So we'll call this long tail or bespoke data. And previously, Scale AI was doing quite well in the data space, but they got nearly acquired by Meta. So there's no clear winner here, and that's exactly where we're operating as Poseidon. So the first wave of foundation models largely operated on text and selected imagery. So you could just scrape the internet, but everybody has access to these pretty common data sets like Common Crawl. So they're not a point of differentiation. So this is echoed by some of the greats in AI. For example, Ilya Sutskever is very early at OpenAI and now has his own startup, Safe Superintelligence. He's essentially saying that, look, we've exhausted all public common training data. And this is also echoed by Elon Musk. And even synthetic data is not good enough because it's just amplifying the biases and trends you already have in public data. So the next wave of foundation models are actually going to be multimodal. So they're going to understand video, audio, maybe even radar and LiDAR, and they're going to take decisions in the physical world. That could be a robotics foundation model or a model that actually makes safety critical decisions in healthcare. So it turns out you need much more bespoke or long-tailed data to train these models. So if you want an AI to learn how to hold this mic and advance the clicker better than me, then you really need a lot of video that intuitively explains the laws of physics via trial and error. That's echoed by the CTO of Meta, but also NVIDIA's humanoid robotics team. So fundamentally, what Poseidon is a training marketplace for AI data. So what I mean by that is in a marketplace, you have supply and demand. So on the demand side, you have foundation model companies. They are eager to gather this long-tail data to train the best models and get a competitive advantage. So this could be a voice foundation model company. And on the supply side, it could be regular Web2 businesses, like a call center. Every day during their operation, they're gathering valuable audio data. So how do you connect this demand and supply and search for it? So that's the marketplace we're building. And the key question here is, how do I make sure all this data is licensable, it's rights cleared, so you can say that it's IP safe. So the key insight here is data is actually intellectual property for AI. So let's unpack what Poseidon really is. So as I mentioned, it's a marketplace. So on the right, you see demand. So this could be a foundation model company for audio or video, and they are the buyers of this data. But they might need some unique data set, say a rare dialect, noisy environments, multiple speakers. So how do they know that they should connect to a call center, say in India, right? So that's the supply side. And let's say another example is a robotics foundation model company. We've talked to several of them. They need egocentric video with depth information in order to train these foundation models. So there are other companies that are Web 2 companies that can collect this data. Imagine a house cleaning service. Every person who cleans this office here has a GoPro, and you collect valuable data in the course of your operations. So the key question of interest is, how do I actually bridge this supply and demand? And that's exactly what Poseidon's building, and it's our so-called AI data layer. So the analogy here is the data you get on the supply side is very messy. It's raw. It's kind of like crude oil. And to take crude oil and refine it to refined oil, I need to go through many steps. So those steps are fundamentally curating this data, cleaning it, so getting rid of statistical outliers. You need to label it, so rather than have humans label this with low-cost labor, say like Scale AI, you can use AI to essentially label the bulk of data and quantify its uncertainty. Only when AI is uncertain, you would ask a human for help. And you would actually search through this data automatically. So you can say, find me examples where a homeowner in Korea put a blue glass bottle in a, say, dishwasher and something broke, right? How do I search through this across petabytes of data? So fundamentally, our data layer has collection, cleaning, curation, labeling, and search. Okay, so the key question of interest is, where's story in all this? So as I mentioned before, AI training data is intellectual property, but it actually has a nuanced kind of interpretation here. So let's take an example. Let's say I'm driving through Seoul and I see a very interesting image from my dash cam. That is IP. And let's say my computer vision model for an autonomous car does poorly, right? There's a new traffic sign, a new environment. That's an edge case. So what I would do today is I would take that IP, that image, and send it to a labeler. That could be Scale AI. And that person would draw bounding boxes and annotate the image. So that's also IP, but from someone else. And now you can actually send that labeled image to an AI agent, so a non-human entity. And that AI agent can create that image in fog, sleet, or snow to stress test the model using stable diffusion. So if you kind of abstract my example, you see a graphical relationship. You have a parent, which is the initial IP. Then you have the children, the child, which is the labeled image. And you see the grandkid, which is the mutated image or remixed image. So this graphical nature of intellectual property is very well suited for stories at one blockchain. So story is of crucial importance to what we're doing at Poseidon. All right, so fundamentally our vision is to build a data layer, an AI infrastructure to organize all the world's AI training data, but put it on-chain. To some extent, you can view this as an Amazon for data. So imagine some foundation model company just logs in, they have a search bar, and they can infinitely find the supply they need for it that comes from diverse places across the globe. So how do we actually build that? So this is a very grand vision, but we only started about 3 months ago. So in the last month, we released our audio app. So it's a decentralized physical infrastructure network, or DPIN app. And you can view this as a reference implementation. It's just scratching the surface, an example for the community how to actually collect data at scale. So let's start from why we're doing this. So everything we're doing at Poseidon is demand-driven. It's based on real conversations with foundation model companies. So we talked to several of them, and they say, look, most public AI data sets are biased towards Western languages. So there's very few public AI data sets covering the Korean market, India, Indonesia, and so forth. And they need data from rare dialects, accents, and with background noise. So how do I collect that at scale? That's the key question I'm asking. So what's interesting here is, if you just throw this out to the world, you'll get a diversity of speakers. And after coming here to Korea, many people have told me they've actually used the app, ranging from the CEO of SK too. But the key question of interest is, how do I figure out this data is not generated by a bot through a text-to-speech API, or somebody is just recording the radio, or it actually comes from a certain person at a certain place and time? So that's where AI and the intersection of cryptography comes in. We're just scratching the surface here, but imagine based on your wallet ID, you get a mnemonic or a seed phrase, and you have to surgically insert this text into a transcript that gives you some indication that the person is dynamically adapting to what you tell them to say. And that's an example of our voice app. So, of course, there are many different languages, but we wanted to show you the Korean data campaign or the voice app. And you can see here, it's you have a transcript to read, you have the seed phrase, and you collect audio, which is intellectual property. So we opened this up to 16 plus languages, and we got a vast amount of data. All right, so as an academic, I was quite surprised by this. We deal with very small data sets. But in just about 2 weeks, we collected about 35,000 hours of audio speech data. This comes from 5.5 million unique submissions and 405,000 geo-distributed users. So this is rather fast. And what's interesting here is, as I mentioned before, AI training data is intellectual property. So this is actually not our data, it's actually yours, the community. So this led to 3.75 million IPs registered on Story, and the Poseidon app became the top AI app on the World App Store. So the key question of interest is this data good? And how diverse is it, right? So we're about to write a research paper on this, but this is just a semblance of some of those ideas. So the x-axis here is the language of interest. The y-axis is the number of hours collected, and this is on a logarithmic scale. So these trends are actually more exaggerated. In blue here is the data collected by Poseidon, and in orange is all public data sets combined. So you can see here that they are definitely dominated by Western languages, public data sets. Even for English, we have dwarfed that in just a couple of weeks. But if you look at the rare dialects or rare languages across the globe, we are clearly increasing the diversity. So if you, sorry, wrong direction. If you see here in Korean, we have many orders of magnitude more than what's publicly available. So let's actually try to break down why this is happening. So I'm taking the previous orange graph, which is all public data sets, and breaking it into its constituent components. So all these data sets here are actually from big tech. So blue is our app. Orange is Common Voice. That's from Mozilla. Then you have Fluors, which is from Google. MLS is multi-language speech data sets. That's from Meta. And in purple is Vox Populi. So what's interesting in purple, Vox Populi is all European parliaments and people speaking on the different floors. So you can see that only European languages have a purple bar. But what the key takeaway here is very few languages have all 4 data sets represented. And you can see here in Korean, you have very little in public data sets. So this is just an example. You shouldn't over-index on this. This is just a reference implementation for audio. But most AI training data, as I mentioned, is multimodal. There's audio, video, LiDAR, radar. We're not going to build an app for that. We want to build what are called subnets. So this is abstracting this and generalizing it so that anybody can put their valuable AI training data on chain. So let's unpack this. So we essentially envision a world where many AI data economies, you can call them subcommunities or subnets, can exist on chain. So let's take an example here. Robotics data, you will need video, but we've talked to many foundation model companies. It's just not general video. You need egocentric video, depth information, seeing me manipulate different objects, and maybe an overhead camera. So that's a vertical specific requirement. Now, if you look on the right for health data, you also want video, But that video should be organized in a similar way to robotics so you can reuse the same machinery. But you might have privacy constraints as well that you need to bake in. So the general idea is you don't want to reinvent the wheel per subnet. You want to have a unified data abstraction, which is on the bottom. That's our data layer that governs or codifies. How do I clean data? How do I label it using new IP from us, using a combination of AI and humans? How do I actually validate that this data is valuable? And how do I search through it seamlessly using natural language? So that's exactly what we're building. So I'm really excited to introduce or unveil our white paper. It's going to be released next week, but it starts from first principles. We've talked to many foundation model companies. What are the real needs today? Why do you actually need to use Web3 and bring this data on chain? And if you want to actually abstract our audio app, how do you actually build a subnet for valuable data for video, LiDAR, and beyond in a seamless manner? So that will be out next week. And with that, I'm happy to take any questions. Thanks for your time.